Hey math enthusiast, I'm here to go over the notes for section 9.5, which deals with compositions of transformations. First term we come across is a glide reflection. So this is a transformation that's going to include a translation, which is going to map P to P prime, followed by a reflection, which is going to map P prime to P double prime. Now, the special thing about the reflection is that that line of reflection is going to be parallel to the direction of the translation. So for this first example, I'm starting off with segment CD. I'm given the coordinates for both of these, and I've graphed them on my graph to the right. So we have C and D. And what I want to do is perform a glide reflection. First part of that is going to be a translation according to this rule that they've given me. So now I want to come up with C prime and D prime. Now the x coordinate is going to stay exactly the same, but for my y coordinate, it's going to be plus 2 units. So C prime is going to be at 1, 4, and D prime is going to be at 5, 6. So that plus 2 tells me that my segment is going to go up 2 units. Now I don't have to graph C prime, D prime. I'm really just worried about the image after the glide reflection is complete. So both parts. Next thing I want to do is reflect over the line y equals x. So if you remember, our rule for this reflection, our point's going to change from xy to yx. Now remember, I'm applying this rule to my new points, C prime and D prime. So that's going to give me C double prime, which is going to be at 4, 1, and D double prime, which is going to be at 6, 5. Now I can graph my final image. On the graph, I now have C double prime, D double prime in blue. Now we have our next definition from this section, composition of transformations. So this is what happens when we have two or more transformations that are combined to produce a single transformation. So a composition of two reflections results in either a translation or a rotation. Now, if this composition of transformation, if it consists of two or more isometries, then the final result is going to be an isometry. So if I end up translating the figure twice and I know that a translation means that the two figures are going to be congruent, then at the end, they're still going to be congruent. Doesn't matter how many times I translate it. The figure is still going to be exactly the same shape and size as the original. Now for the next example, I'm starting off with triangle ABC, which I did graph off to the right, but you don't have to. I'm really only worried about graphing the image in this problem. So we have points A, B, and C, and what I want to do is perform a composition of transformations. So let's start off with the first movement. First thing I want to do is translate the figure according to the rule that they're giving me. So I've jotted down my original points, and for my translation, first thing I'm going to do is subtract 2 from my x coordinates. All of these, I'm going to subtract 2. And then for my y coordinate, I'm going to add 3. Now, since I'm subtracting 2 from the x coordinate, I know that means I'm going to be going left 2 units. And if I'm adding 3 to the y coordinate, I know that means I'm going to be going up 3 units. So after this translation, I get my new coordinates, A prime, B prime, and C prime. Now I'm going to clean this up a little bit and make space for our next transformation. So the next thing I want to do with my points is now I want to rotate them. Now remember, I'm rotating my new points, A prime, B prime, and C prime. Right now I'm done with A, B, C. So what I want to do is rotate 90 degrees, but the problem is it's about this point 0, 2. We do have a rule to rotate 90 degrees, but it's when it's centered at the origin. So what I want to do first is I want to take that center of rotation and I want to move it so that it's at the origin. So in order to do that, what I'm going to have to do is first, I'm going to have to translate all my points. So I'm going to have to come up with a rule to get the center of rotation to the origin. So as I marked on the graph, what I need to do is I just need to go down 2 units to get that to the origin. I'm not going left or right, so I'm not going to add or subtract anything to the x. And for my y coordinate, I'm going to subtract 2 in order to go down 2 units. So now I have my new coordinates, a double prime, b double prime, c double prime after that translation. Now, since the center of rotation has moved to the origin, now the center is at 0, 0, now what I can do is actually perform the rotation. So we have a rule to rotate 90 degrees about the origin. My point's going to change from x, y to negative y, x. So now I want to apply that rule to my new points, a double prime, b double prime, c double prime. So now I've come up with my triple primes. So I did successfully rotate the figure, but the problem is I had translated it before. So now what I need to do is I need to undo that initial translation that I did. So I want to translate it back to where it came from. So originally we had moved it 2 units down. So what I'm going to do is I'm going to take those x, y coordinates and I want to move them up 2 units. I'm going to go back to where I came from. So I'm going to have y plus 2 for all my coordinates. And this is going to end up with quad prime points. But that's going to be the end of the movement. So now I have the coordinates for my final image after the translation and the rotation. So last thing I'm going to do is just graph that image. So now I have a quad prime, b quad prime, and c quad prime on my graph. So remember what we did was we translated first 2 units to the left, 3 units up, and then after that I rotated 90 degrees counterclockwise around that point 0, 2. Next example I come across is a little different. Okay, the transformations have already been completed, but I need to determine what type of transformations took place. So it looks like this solid figure is my original. So we'll label that one with a 1. That's my first one, my pre-image. Then it moves to the single prime. We'll call that then the second one. And then it finally moves to the double prime. That's my third one, or final image. So the first thing I got to figure out is how did I get from figure 1 to figure 2? All right, well, I noticed that C is on top in figure 1, but now all of a sudden B is at the top for figure 2. So that tells me right away it's not a translation. All right, and it doesn't appear to be a reflection. It's not like the figure is flipped over a line. So I'm going to go with rotation for my first type of transformation. But now I got to figure out, 1, how many degrees it has rotated, and about what point. So it looks like if I focus on, let's say, point C, since I highlighted that earlier, point C turned over to become C prime. All right, so in this case, we're really only dealing in terms of 90 degrees. So it's either 90 degrees, it's either 180, 270, or 360. All right. It looks like in this case, since C has not moved all the way to the bottom underneath my triangle, then I'm going to go with 90 degrees. So it's a 90-degree rotation. And in this case, remember we were heading this direction. So that's the other thing I want to include. All right, so it looks like we went 90 degrees, and it looks like in this case it was 90 degrees clockwise. Now, typically the default is counterclockwise. So if you wanted to switch it to counterclockwise, we can do that. All right, but it's not going to be 90 degrees anymore. So what I'm trying to figure out is if I were to rotate it counterclockwise, how many degrees did I go around to get to my new point? All right, in this case, if it's 90 clockwise, that means it's going to be 270 counterclockwise. Now, you don't have to include both of these, one or the other. Doesn't matter. And the next thing I want to include is what's my center of rotation? Typically it's around the origin. All right, but in this case, if you notice, A and A prime are at the same exact location. All right, it has not moved. So what that tells me is that my center of rotation is at that point because A and A prime are in the same exact location. So my center is going to be at -2, -1. Okay, so we're done with the pre-image. Now I need to figure out how did I get from figure 2 to figure 3. Well, if you notice, they're oriented the same way. B's on top here, B's on top here. C is to the right, C is to the right, A is at the bottom, A is at the bottom. All right, so it's not a rotation in this case. And it doesn't look like a reflection because it hasn't been flipped. It's oriented the same exact way. So for this last type of transformation, I know right away it has to be a translation. So the next thing I need to come up with is what's the rule? Yeah, I translated, but how did my figure move? Did it move to the left or right? Did it move up or down? So if we focus on point A prime to point A double prime, it looks like we went 1, 2, 3, 4, 5 units to the right. So that's going to be x plus 5. And it looks like we went 2 units down. So that's going to be y minus 2. And there's my rules. So I know it was a rotation followed by a translation. Now the next part of the notes has us thinking about what happens if I perform 2 reflections over parallel lines. So we can see that we reflected segment QP in this picture over line K to start, and I get P prime Q prime. And then I reflect it again over line M, which is parallel to line K, and I get Q double prime, P double prime. So if I compare my original QP to my final Q double prime, P double prime, it almost looks like all I did was just slide that segment to the right. So anytime you have a double reflection like that over parallel lines, it's going to appear as though it was just a translation. The next thing you might notice in this picture is that if I connect P to P prime to P double prime, this segment compared to the parallel lines that I have here, K and M, notice that it forms this right angle right here. All right, that segment P to P double prime is actually perpendicular to lines K and M. And for the last part of this notes, I want to compare the length of P to P prime, so that entire segment. How does that compare to the distance between these parallel lines right here? All right, obviously they're not equal. But what is true is that P double prime is going to be equal to double the distance between the parallel lines. So if this is D right here, the distance between the parallel lines, I know P to P prime is going to be twice as long as that black segment below. So let's see if we can apply all that information to this example here. So first thing they tell me is R and S are parallel. So these are the vertical lines here. They also have the little extra arrows on here, which tells me that they are parallel. So we have segment CD, it's reflected over line R, and then C prime D prime is reflected over line S, similar to the example that we just saw. So the first thing they're asking, a translation on segment CD. So if I were to take CD and translate it, it would move directly on top of C prime D prime. Or sorry, double prime. C double prime, D double prime. Next thing they want to know is which lines are perpendicular to D double prime. So if I were to connect them, D to D double prime, looks like the two lines that would be perpendicular to it, that are forming a right angle here, would be the vertical parallel lines. So it would be line R and line S. Next, they want a segment that's parallel to C double prime. So C to C double prime. So obviously it's not going to be line S or line R because that intersects that segment, but it looks like the segment that we were focused on earlier, D to D double prime, it looks like these two segments are going to be parallel. All right? Because if you think about it, they're both perpendicular to those parallel lines. So my answer is going to be D double prime. And for the last question, they tell me the distance between R and S is 2 inches. So 2 inches in between the parallel lines. What they want to figure out then is how long is C to C double prime. So if you remember what we learned earlier, the two are clearly not equal, but in fact that distance between R and S is half the length of C double prime. Or C double prime is going to be double, so it's going to be 4 inches, double the distance between the parallel lines. So the final part from this section talks about reflecting over intersecting lines instead of parallel lines. So for example, if I start with point AB, I reflect it over line K, I get A prime B prime. I reflect that over line M, gives me A double prime B double prime. Okay, and essentially to get from the pre-image to the image, what I could have done was just rotate AB to get to A double prime B double prime. So this theorem is essentially telling me if that I reflect that segment over one line, then reflect it over another line, and the two lines are intersecting, then my final result is a rotation. And the last thing they discuss is the angle of rotation. So you have your two lines, they intersect. The angle they form is x degrees. But the angle of rotation, so from this segment all the way to this segment, so this angle in blue is actually going to be double the size of the red angle. So in this case, the angle that they rotated is actually going to be 2x. So the angle of rotation is 2x, where x is the measurement of the acute or right angle formed by my two lines K and M. So for this final example, I started off with my pre-image T, this lightning bolt down here. I reflected over line K. I got T prime, this lightning bolt, and then I reflected over line M. And finally, I got this lightning bolt T double prime. Now, it looks like the angle that the intersecting line form is 75 degrees. But what I'm trying to figure out is if this is my center of rotation, how far did it rotate? So I went from T all the way to T double prime. So what I'm trying to figure out then is how large is this blue angle? All right, and in this case, based on what we learned from the previous notes, that angle of rotation to get from T to T double prime is going to be double the angle that the intersecting lines form. So in this case, my angle of rotation is 150 degrees.